So welcome back students. So today in 9th standard mathematics what you are going to see means in set language. So types of sets continuation. Types of sets continuation already you have studied finite set, infinite set and next one is what? Correct, empty set and next one singleton set and what you have studied cardinal number of a set and next equal sets and then very good, equivalent sets. So now what you are going to learn means you are going to learn universal set. So what is meant by the word universe? So universe means what? It contains galaxies, space, stars. So here the universal set is denoted by letter U. Universal set is denoted by letter U. A universal set is a set which contains all the elements of all the sets. So all the elements means what you will write? So 1, 2. So again what you have B is equal to 2, 3. So 2 is here, you won't write 2. So 3 and next one C is equal to 3, 4, 5. So 3 you have written. So next 4, 5. So universal set is the all the elements is a set of all the elements of the all the sets under consideration. So universal set is denoted by what? Letter U. Suppose if you have U is equal to, we have discussed about the natural numbers. So you will write U is equal to X such that U is the set of natural numbers. How you will write means U is equal to X such that X belongs to N. U is equal to X such that X belongs to N. Suppose if you are taking A is equal to Earth, Mars, Jupiter. So A is equal to set A is equal to you have taken as what? Earth, Mars, Jupiter. So what will be the U? So what are these? So Earth, Mars and Jupiter you have studied in science. What is this? So these are the planets on the solar system. So set U, universal set U will be the planets of the solar system. Universal set U is the planets of the solar system. Have you understood? So what is meant by universal set? So universal set means universal set is a set. It contains all the elements of all the sets under consideration and it is denoted by letter U. Have you understood? So next one we'll move on to disjoint sets. So disjoint set means, so from the word itself you can understand. So both the sets are separated. So it is disjoint. Set A is equal to A, B, C. Set B is equal to D, E, F. So here whether the elements, any element is common in A and B? No. So disjoint sets means, so if you are taking two sets A and B, so you will not have common elements. You won't have common elements. So that is called what? Disjoint sets. So next one is overlapping sets. So what is meant by overlapping sets means, suppose if you are taking A is equal to P, Q, R and B is equal to R, S, T. So here P is there, so in set B P is not there, R, Q is there, here Q is not there, R, R. So at least one element should be common. So overlapping set means, so if you have at least one element common, so it is called as what? Overlapping sets. It is called as what? Overlapping sets. So next one in exercise 1.2, fifth sum. State which pair of sets are disjoint or overlapping. So in the first subdivision what is given? A is equal to F, I, A, S and set B is equal to A, N, F, H, S. So here F is there, here also you have F. Next one I, so I is not there, here A is there, here also you have A. So next one here S is there, in set A S is there, here also you have S. So you have three common elements. So if you have at least one itself, it is a overlapping set. So here three elements are common. So you can say this as what? Overlapping overlapping set. So this is an overlapping sets. So next one, C is equal to, second subdivision, C is equal to x such that x is a prime number greater than 2. So prime numbers greater than 2. So only they have given greater than 2. So what you will take, C is equal to, you will write it as 3, 5, 7. So what is meant by prime number? A prime number is a number divisible by itself and it is divisible by 1. So 3, 5, 7, next one 9, 10 it won't come. So 11 etc. it goes on. So next one, D is equal to x such that x is a even prime number. So you all know only even prime number is, it is 2. Only even prime number is, it is 2. So here whether you have any elements common, so you don't have any common elements. So you, what you will say? You will say this as what? Disjoint sets. You will say this as what? Disjoint sets. Disjoint sets. Next one, third subdivision, set E is equal to x such that x is a factor of 24 and f is equal to x such that x is a multiple of 3 and x less than 30. Multiple of 3 and x is less than 30. So E is equal to, so x such that x is a factor of 24 means the numbers divisible by 24. So what are the numbers divisible by 24? 1, 2, next 3 because 8 3s are 24, next 4, 6 4s are 24, next one 5 it won't come, 6 4s are 24, 7 it won't come, so 8 3s are 24, so 9, 10, so 12, 11, 12 and next what you will get? 24 itself. So 1, 2, 3, 4, 6, 8, 12, 24 and f is equal to, x such that x is a multiple of 3 and x is less than 30. A condition is given, it is less than 30. So less than 30 means, so you should not include 30. So what are the numbers you will include? 3, 6, 9, then 4 3s are 12, 5 3s are 15. So these are the multiples of 3. Next 6 3s are 18, 7 3s are 21, 8 3s are 24, 9 3s are 27. So check whether any common elements are there. So here 3 is there, here also you have 3 and next 6, 6 and next one. So here you have 12, 12 and next 24. So here also you have 24. So you have common elements in these two sets. So if you have common elements means what you can say? It is an overlapping sets. So it is what? Third subdivision is overlapping sets. So it is called as what? Overlapping sets. So now next one in types of sets, we are going to learn about subset. So you are going to learn about what? Subset. So we will see one example. So A is equal to A comma B and B is equal to A comma B comma C comma D. So A, what you have? A comma B and B is equal to, set B is equal to A, B, C, D. So here what you can say means A is the subset. So this is the subset symbol. So now you are going to learn the new symbol, that is subset symbol. So one C, then down you have one dash. So A is, you can say also read as A is contained in or equal to B. A is contained in or equal to B. So from this what you can say means, so every element of A is in set B. Every element of set A is in set B. That is A is equal to what? A comma B. So in B also you have the elements A comma B. So in B also you have the elements A comma B. So that is from this itself you can say the definition. So if you are taking the two sets A and B, every element of A is in set B. So then you can say it as A is the subset of B. A is the subset of B. So from this you can say, so how many elements are there in set A? So n of A is equal to 2 and how many elements are there in set B? So n of B is equal to 4. So from this what you can say? N of A is less than or equal to n of b. n of a is less than or equal to n of b. So that is number of elements in A should be less than number of elements in B. Then only you can say it as A is the subset of B. A is the subset of B. Suppose if you have more elements in A, that is A is equal to, so if you have more elements in A, B, C, D, and B is equal to, so you have A, B, C. So if you have more elements in A and B only you have 3 elements means, so from this what you can say means A is not the subset of B. A is not the subset of B. So one more condition is also therefore not a subset of B. That is A is equal to, suppose A is equal to P, Q and B is equal to R, S, T. So here A is equal to P comma Q and B is equal to R, S, T. So what is meant by subset? Every element of A should be in B also. So here entirely different. Here you have P comma Q. So in B you don't have P comma Q itself. Then also you can say it as what? A is not a subset of B. A is not the subset of B. So two condition of this. Suppose if A has more elements, then you will say it as A is not the subset of B, or else if you have entirely different elements in A and B, so you will say it as what? A is not a subset of B. So what is a subset means? So if you are taking two sets A and B, that is every element of A should be in B. Then only you can say it as what? A is a subset of B, or else you can say it as A is contained in. So the C, like C, A is contained in or equal to B. A is contained in or equal to B. So now based on this we will see one example, that is example 1.6 in your textbook. Insert the appropriate symbol, subset or not a subset in each blank to make a true statement. So in first subdivision what you have? 10, 20, 30. Suppose if you keep this as A, set A is equal to 10, 20, 30 and keep this B is equal to 10, 20, 30, 40. So that is every element of A. So 10, 20, 30. Here also you have what? 10, 20, 30. So every element of A is in set B. So what you can say? A is the subset. A is the subset of B. And next one, second subdivision if you see means P, Q, R, and here what you have? So keep this as C. C is equal to P, Q, R, and this let D is equal to W, X, Y, Z. So here you have P, Q, R, elements are P, Q, R, here W, X, Y, Z. So entirely different elements are there. So what symbol you will insert? Can you anyone say? Very good. So you will insert what? It is not a subset. C is not a subset of D. C is not a subset of D. So n of A is less than or equal to n of B means you will say it as A is subset of B. So here if you see means A is equal to A, B, C, D. B is equal to A, B, C. So here what is n of A? Here n of A is equal to 4 and here n of B is equal to how many elements are there? 3 elements are there. So here n of A is greater than or equal to n of B. So what you can say means B is the subset of A, that is n of B is less. So how you will write? N of B is less than or equal to n of A. So you can say here as B is the subset of A, but A is not a subset of B. Here you can say it as B is the subset of A because A has more elements. A has more elements, so you can say it as B is the subset of A, but A is not a subset of B. Is it clear? So now in subset, so we will see one example, that is write all the subsets of set A is equal to, so what is given here? Pen, pencil. So listen. So here set A is equal to pen, pencil it is given. So you are going to write the subsets of A. Subsets of A are, so what I said subset means it is a part of a set. It is a part of a set. So now listen. So pen and pencil is there. So how many of you need pen and pencil? So here we'll ask Rani. So how many of you need pen, pencil? So she doesn't need anything. So she don't want pen and pencil. So It is an empty set because she don't want pen and pencil. So next one, Raji. So whether you need pen or pencil. Okay, pen. So she needs pen. So she needs only pen. Understood? So next one. So we'll ask Viji. So whether she needs pen or pencil. What you need? Pencil. So she needs only pencil. She needs only pencil. And next one. So we'll ask another person. So whether you need pen or pencil. So she needs what? Both pen and pencil. So she needs both pen and pencil also she needs. So from this what you can say means empty set is a subset of every set. So empty set is a subset of every set. So next one, so every set is a subset to itself. So every set is a subset to itself. Empty set is a subset of every set and every set is a subset to itself. Have you understood? So next one, so in example 1.7 from your book, write all the subsets of set A is equal to A comma B. So elements are given as what? A comma B. So what I said? Empty set is a subset of every set. So empty set is a, so subsets of A are, subset of A are, so empty set is a subset of every set. So next one what you will write? A, and next one B, then again what I said? A set is a subset to itself. So A comma B, every set is a subset to itself. So A comma B. So what are the subsets? One is null set, that is empty set is a subset of every set, then A, B, then every set is a subset to itself. So next one what you are going to see means subsets is classified into proper subset and improper subset. Subset is classified into proper subset and improper subset. So in proper subset, suppose if you are taking A is equal to 1, 2 and B is equal to 1, 2, 3, 4. 1, 2, 3, 4. So here for proper subset, what does this symbol means? A is the proper subset of B. A is the proper subset of B and one condition is that is A is not equal to B. A is not equal to B. That is A is contained in B. That is every element of A is there in B, but A is not equal to B. So in proper subset what you have? A is equal to 1 comma 2, B is equal to 1, 2, 3, 4. So that is A is the proper subset. A is the proper subset of B. So that is A is contained in B. So you can say it as what? A is contained in B. So what is the condition? A is not equal to B. So here what is N of A? N of A is equal to, N of A is equal to 2 and N of B is equal to 4. So N of A, here it should be less than, N of A should be less than N of B. N of A should be less than N of B. But in subset what you had? N of A is less than or equal to N of B. N of A is less than or equal to N of B. But in proper subset, N of A should be less than N of B. So that is A, why? Because A is not equal to B. A is not equal to B. So next one in improper subset, we will move on to improper subset. Suppose if you are taking A is equal to 1, 2, 3. A is equal to 1, 2, 3. So improper subset means, so every set is a subset to itself. Every set is a subset to itself. So improper subset of A. So what is improper subset of A means? So improper subset of A is equal to, what you will write means, a subset to itself. Every set is a subset to itself. So that is A is equal to 1, 2 and 3. So now we will see another example, that is write all the subsets, then proper subsets and improper subset. So what is given here? A is equal to A comma B. A is equal to, set A is equal to A comma B. So first you will write subsets of A are, subsets of A. So what will be the subsets of A? So empty set is a subset of every set. Empty set is a subset of every set. So next one, first what you will write? So you will write what? A. Then next what you will write? B. Then you will write A comma B. Then you will write A comma B. That is, every set is a subset to itself. Every set is subset to itself. Next one, proper subsets. So next one is what? Proper subsets of A. So what are the proper subsets of A? So empty set. First you will write what? Empty set. Next one what you will write? So you will write A. Then next what you will write? B. Next what you will write? B. So empty set. Then next one set A, and next one is set B. Next one, improper subset. So improper subset. So improper subset means, so what you will write? So every set is a subset to itself. Every set is a subset to itself. So what you will write? You will write only A comma B. That is, every set is a subset to itself. So can you identify the difference? So subsets means what you will get? So empty set, set A, set B, set A comma B. Then proper subsets of A are null set, set A and set B. Next one, improper subset. So what you will get? You will get A comma B. That is, every set is a subset to itself. So next we will move on to power set. Power set. Suppose if you are taking A is equal to x comma y. What will be the subsets of A? So subsets of A are null set, and next one what? X, and next y, and next is x comma y. So these are what? Subsets of A. So power set is nothing. So power set means, so you will denote it by P of, power set is written as P of A, power set of A. The set of all subsets, the set of all subsets is power set. So nothing is there. So you have to insert the bracket alone, curly braces alone you have to write, that's it. So set of all the subsets. So empty set, x, y, then x comma y. So the set of all the subsets, it is called as what? Power set. So you have one note, that is, if n of A is equal to m, then n of P of A is equal to 2 to the power m. Suppose if you are taking A is equal to, so A is equal to 1 comma 2. So what is n of A? So n of A is equal to number of elements in set A. So n of A is equal to 2. So next one, number of subsets. So number of subsets, how you will find out means, so n of P of A, n of P of A is equal to 2 to the power m. That is, so how many subsets will be there means, so 2 to the power, so this m is the number of elements in set A. So that is 2 squared is equal to, you will get 4. So here itself you can check it. So A has how many elements? 2, 1, 2. So how many subsets are there? So you will get 1, 2, 3, 4. Suppose A has 3 elements. N of A is equal to 3 means, so what will be the number of subsets? The number of subsets will be 2 to the power cube. So what is 2 cube? 2 into 2 into 2, that is 8. So second one, the number of proper subsets. So how you will find out the number of proper subset means, suppose A is equal to 1 comma 2 and n of A is equal to 2. So number of proper subset means you have to subtract 1. That's it. So n of P of A minus 1, that is 2 to the power m minus 1. That is 2 square minus 1, that is 4 minus 1 is equal to 3. So from here you can check it. So proper subsets of A are null set, then A, then B. Next one, improper subset. So improper subset is A comma B, that is every set is a subset to itself. So now can you say the power set? So power set means what I said, the set of all the subsets. So the set of all the subsets means, oh, nothing is there, you have to insert the curly braces. So null set A, B, then A comma B, close it with the curly braces. So this is the power set. So power set, can you identify the difference? Subset, proper subset, improper subset and power set. So in exercise 1.2, so we will see the 10th sum, that is if n of a is equal to 4, find n of p of a. So n of p of a means number of elements in the power set, number of elements in the power set. So what is n of p of a? N of p of a is equal to 2 to the power m. So this m denotes what? Number of elements in the set A, number of elements in the set A. So here what will be n of p of a? So n of p of a is equal to 2 to the power 4. So 2 to the power 4 means how you will write? 2 into 2 into 2 into 2, that is 2 2s are 4, 4 2s are 8, 8 2s are 16, 8 2s are 16. So next second subdivision. If n of a is equal to 0, n of a is equal to 0, find n of p of a. So same thing only. So n of p of a is equal to, number of elements in the power set is equal to 2 to the power m. N of p of a is equal to 2 to the power m. So n of p of a is equal to 2 to the power 0. So what is here? N of a is equal to 0. So any number raised to the power 0 is what? 1. 2 to the power 0, that is equal to 1. So 3 to the power 0, 4 to the power 0. So any number raised to the power 0, it will be what? 1. So here n of p of a is equal to 1. Number of elements in a power set is equal to 1. So next example. So if n of p of a is equal to 32, n of p of a. So see the difference here, n of a is given, you found n of p of a. So here what is given? Number of elements in the power set is given. So that is equal to 32. You have to find out the number of elements in the set A, number of elements in the set A. So what is n of p of a? Number of elements in the power set is equal to, how you will write? 2 to the power m. So you have to write it in the terms as, so your base should be 2, base should be 2. So 32 you divide it by 2 and see, 32 you divide it by 2. So what you will get here? 16. So next one 8, next 4, 2, 2, 2. So how many are there? 1, 2, 3, 4, 5. So n of p of a. So this 32 can be written as what? N of p of a is equal to 32, it is given. So this 32 can be written as what? Your base should be 2. So 2 to the power 5. So what will be n of a? So n of a is equal to, so this m only is what? M only is the number of elements in the set A. So here n of a is equal to what you will write? 5. N of a is equal to 5. So now you have learnt types of sets fully. So you have learned how to identify the types of sets. So you go work down all the sums in exercise 1.2 and you work down all the example sums also in the types of sets. So write it in your note, all the definitions of the types of sets and learn properly.